second year in a row, so that's just fantastic. James has been leading ESA's lunar efforts for quite some time. We worked together for a long time. So thanks for coming. He's going to be talking about building ESA's lunar exploration mission capabilities.
Thank you very much, Greg. It's an absolute pleasure to be here because the weather is much better. Thank you. Yeah, thanks for having me again. I'd like to give you an update on what ESA is planning and what we're doing in the area of lunar exploration, what our aspirations are and what we're doing about it. The first thing really to say is that for a long time, ESA policy has been that the next destination for human exploration after low Earth orbit is the moon. And so we have for a long time been trying to build the capabilities or to pathfind a way to get humans back to the surface of the moon. And that is what we would like to do. And so I'd like to start with this image, which is an image of the moon. And in the top right, you will see the International Space Station passing over the front of the moon. Now, international cooperation is something which is at the heart of the European Space Agency. We are a cooperation of 22 different countries working together to do stuff in space, and that's quite extraordinary. And the ISS is another great example of international cooperation. If I think about the world today, there is one place I can think of where the whole of Europe, Russia, the United States, Canada, Japan are working together to do extraordinary things, and that's actually there on the International Space Station. And that, for me, that justifies the space station regardless of anything else. I think that gives us hope as a species that we can do extraordinary things when we work together and cooperate. And so there's a reason why ESA's exploration strategy is actually entitled Exploring Together. And international cooperation is really at the heart of it. Partly because we in Europe realise that we don't have the budget to do this on our own, so we have to work with everybody else. But also, as part of international cooperation and building cooperative ties with other nations is actually a fundamental part of the ESA exploration strategy and is a goal in of itself for the agency. So with that in mind, if we look forward to a further future, what exploration on the moon might look like, there are some fundamentals that just have to exist in order for that to work. So the first of all, you have to get there. Once you're there, you have to be able to communicate with each other on the surface and back to Earth. You have to be able to operate at the surface effectively and efficiently. You need to survive while you're operating there. You need to be able to move and have ability across the surface. And you're going to have humans and robots working together. And so you need to be able to optimize the way that humans and robots are working together to get the best out of both and to be able to maximize the return that you get from both these parts of your infrastructure. So this is what we're going to try and get. Oh, and by the way, and also, of course, you have users. And so when you're at the surface, you're doing things, and it's the users of these facilities and these capabilities which ultimately justify what you're doing there and give you the return on your investments. So you have to build a user community as well. So in terms of getting there, we can get a large part of the way there with MPCV. So ESA is involved in the multipurpose crew vehicle, Orion, which is being led, of course, in the USA. So this part at the back is the service module. So ESA is delivering that service module for MPCV. And so for Europe, this is a big deal. This puts us on the critical path of human transportation for the first time after many years of trying to do that in Europe. So that's important. It also gives us access. This is the vehicle that is going to take humans beyond low Earth orbit. And so that's very, very important and as a strategic element in what ESA would like to do later. So that's going to get as far as cislunar space, but not to the lunar surface, of course. And in cislunar space, it is the intention that it will meet what we call the cislunar transfer habitat. Now, this is something which is under discussion with international partners in various contexts, including through the ISS partnership and through the International Space Exploration Coordination Group. It's something which we are studying in Europe, internally in ESA and with our industry, and I know that studies are going on elsewhere in the world as well as to what this might look like and what different international partners might provide to this. So for ESA, this is not a destination in of itself. It's somewhere you go on the way to the surface. It's something that we think we can do within the next few years with the budgets that we think we would have available and provides really an access point, a staging point to get to the lunar surface. So something we are looking at is how you can leverage this asset to get humans back to the lunar surface in the sort of 2030 timeframe. but also how, in advance of that, we can run we call the human precursor campaign, where we can use this to operate robotics at the surface of the moon to do exploration of the surface in advance of human missions to prepare the technologies and capabilities that we would need then. And so we're in discussions with international partners about what these robotic precursor campaigns would look like and what different international partners would bring to those. So in terms of getting from cislunar habitat to the lunar surface, or from the Earth surface to the lunar surface, we are working very closely with Russia on the Russian lunar exploration plan. So Russia have a series of lunar missions, you'll see on the bottom here, starting with the Lunar 25 or Lunar Globe Lander, which is planned for the 2018. So we're supporting these missions by providing ground support and providing payloads for it. But the key thing for Lunar 25 with the Precursor and then Lunar 27 is we're providing something called Pilot, which is a precision landing and hazard avoidance system to allow landing sites to be targeted on the scale of a few hundred meters at the lunar surface. We're also working with the private sector on starting now a public-private partnership for lunar access, working with Airbus Defence and Space, who are one of the largest space system integrators in Europe. And we're working with international partners to look at what options could be for a human-rated lunar lander. Looking at, again, what different international partners might contribute to that, and we're making some progress towards defining what an international human lunar lander going from cislunar habitat to the lunar surface might look like. So once we're there, we need to communicate and operate. So again, working with our Russian colleagues, we're providing a service to them, which we call Spectrum. So this is a communication service that we can offer to partners using the extensive ground station network and operations capabilities that we have in Europe for our missions. We're also looking to creating a UHF transceiver, which we can put on orbital platforms, which can provide relay capabilities, and we're looking to develop that as well, although it's probably not going to be available for the Russian missions. We're also, again, working on a public-private partnership with two companies, Surrey Satellite Technology Limited and Goonhilly Earth Station, who have an idea for a commercial lunar communications relay spacecraft. This was announced last week at the Farnborough International Air Show in the UK, and this would be available from 2019 as a commercial service to anybody who's at the moon and would find that useful. And I'll tell you a little bit more about that in a few minutes. So then, one of the key capabilities for being at the lunar surface and creating sustainability seems to be to live off the land. And so we'd like to understand what the possibilities are. And so building on what Dana was talking about earlier, these lunar polar volatiles, we want to try and answer some of these questions about the abundance, the distribution, the viability of lunar polar volatiles as a resource. And so for that, we are developing the Prospect system, which is a drill and sample analysis end-to-end capability, which is being developed to analyze water ice and other volatiles which would be in the lunar polar regions. We'll look at the abundance, the distribution with depth, and we'll provide very, very comprehensive isotopic measurements of the volatiles that we find there. We'll also look at some chemical processes for extracting oxygen from minerals in the regolith, and just so happens it will deliver some pretty cool fundamental science too. But so it's a good example of leveraging what is an exploration motivation to deliver some really good science at the same time. So we have a fantastic team of scientists who are working with us and to develop that. But one of the challenges here is that the Prospect will be on the Lunar 27 platform, which is a static platform. So one of the reasons why we push things like isotopic measurements is to really pull the maximum amount that we can from a stationary lander. But if you really want to do comprehensive measurements, if you want to understand the broader distribution, then there are other things that we would need to do. So we've had a mission study running with two industrial contractors, Thales Alenia Space and Airbus, to look at a lunar volatile Prospector mission, which would be a rover mission, similar in many respects to the RP mission that's being studied here. And we've also been looking at a lunar polar sample return mission, again with Thales, Alenia Space and Airbus, which would be a partnership with Russia, and is a mission. The idea for that mission really has come out of Russia, And that idea for that mission would be to return cryogenically preserved samples from the lunar polar regions to the Earth for study in terrestrial laboratories. Both these studies actually were just coming to the end now of the sort of pre-phase A level studies. Both these studies have surprised me tremendously because I thought they were both impossible when we started, and I thought the message at the end of the studies would be we can't do it. What's really surprised me is in both studies we have some very smart people working on them, and they look possible. So that's very encouraging, and I think that both these missions are something that we're interested to try and pursue a bit further. We're interested in how we can work with international partners to realise some of these missions. We also have activities looking at additive manufacturing or 3D printing at the lunar surface, both to manufacture things, but also for construction, to build lunar habitats. And we've had some fantastic work going on with architecture companies, even a company called Foster and Partners, a very famous architecture company in the UK, to develop ideas for lunar surface habitats based on 3D printing. And we've done some demonstrators creating building materials using 3D printing technology and regular simulants. And we also think that small sat platforms are going to have a really important role to play, and so we're looking now into what CubeSat kind of platforms can do to lower the entrance barriers for many to get into this area and see what we can pull out of those kinds of platforms to support exploration. Again, I'll talk a bit more about that in a moment. Once we're at the surface, you have to survive and work. So in Europe, we have extensive experience of developing habitats for ISS. I may get this number wrong, but my recollection is that something like 70% of the pressurized volume of ISS was built in Europe. So we have a very strong heritage in this area. And in terms of things like closed-loop life support, for example, I think I can say that Europe would claim to be the lead in this area, and is something that we'd be very interested in providing for future missions. And of course, 3D printing of habitats, which I mentioned earlier, is in an early stages of technology development, and this is actually the concept that came from Foster and Partners for this lunar habitat based on 3D printing. So we want to operate humans and robots together. So we are looking at teleoperations from ISS, for example, as an analog for the kind of things you might do from the cislunar habitat, teleoperating robotics at the surface. So this is a British astronaut, Tim Peake, a few months ago working on the ISS, teleoperating a rover, which was in Stevenage in the UK at the Airbus Defence and Space. So doing teleoperations, trying to work out what is the optimal balance between human in the loop and autonomy on the ground, and how can we really optimize that interface. And at the same time, we also have other technology activities running, particularly one called Lucid. And Lucid is about situational awareness, and again, looking at this balance of teleoperations and autonomy, but really focused there on a lunar polar volatile prospecting mission concept and trying to understand how you would operate in that environment most effectively. So finally, we're looking at the role of small sats, and again, this is where I bring up again this public-private partnership, which is coming together with Dunhilly and SSTL for the Lunar Communications Relay. Now, this mission concept, which is a commercial mission concept, would have a mothership going to lunar orbit, and the mothership would provide communications relay capabilities for anybody who happens to be at the moon. But this mothership will carry a commercial payload of CubeSats and SmallSats, NanoSats, which are available on the market now to be purchased, these slots. These would then be deployed into lunar orbit, and this mothership will provide communications relay capabilities for those SmallSats. So if you have been looking at a CubeSat concept for a while and you're looking for a mission opportunity, I'd be very interested to talk to you. I also have a bunch of leaflets, which I'll keep some on me. I'll put some somewhere you can find them. And I know that these guys would be really excited to hear from you, so they can discuss with you about how they can meet some of your needs for your lunar mission in 2019, which is when they want to go. And we're also starting a competition within Europe in the next coming weeks to look at small sat mission concepts based off CubeSat platforms or small sat platforms to do resource prospecting, to understand environmental effects, to do fundamental research, and demonstrate technologies which will be used for future exploration. So we have quite a number of activities running, and we can take this forwards. So if we think about the future, the long-term vision, I would be surprised if anyone here hasn't heard of the Moon Village. So Moon Village is it's an idea that has come from the new Director General of the European Space Agency for something that he thinks would make sense as something for the international community to do post-ISS as a focal point for the international community. And he sees this as not so much a program, this isn't a program, he sees it as a movement, something which should be inclusive for all countries, for all people, for the commercial sector, for the private sector, for public sector, for individuals, and it would be a place that has multiple uses, used by multiple users, and would really become something which is a village. And so he's used that word very carefully. So this is something that he's interested in exploring, and I think that all these different aspects of public, private, national, international, building different users and user communities is something that we are trying to do now through our approach. And so this is a long-term vision. This isn't going to happen straight away, but I think that the stepping stones that I've talked about, which are things that we're going to be pursuing in the coming year or two, are going to be really important in getting there. So we're developing the missions and systems with international partners through flight projects, through technology developments, through building partnerships with the international partners and the commercial sector. But the next steps for us are going to be decided in December of this year, where we have our, every 3 years we have a ministerial council meeting where the ministers in the governments of the 22 countries that are members of ESA decide on the budget and priorities for ESA over the next 3 years. And so we're currently now working on a proposal for them, which would wrap up in a single program, all of exploration and human spaceflight, including ISS, Moon and Mars. And all of these aspects that I talked about will be a part of this envelope program. And we're optimistic that this will set us in good stead for the coming years. So that's where I'll finish. So thank you very much.
So we have time for perhaps 1 or 2 questions. Please, if you could go to the microphone.
Regarding crewed operation in cislunar space, 2 things. One is the plan for concept for radiation protection at the same level you'd be in interplanetary space for long-term occupancy? And the other is operating things on the surface. Can you describe the advantages of doing that from cislunar space? I can see at Mars because of the light travel time, but...
Okay, so the first thing is the radiation environment would be the interplanetary radiation environment. So actually one of the key things that we'd be looking to study is what are the effects of that deep space radiation environment on human physiology. So that's something which is, it's one of the big unknowns for deep space exploration for humans. It comes up time and time again. And actually in terms of research, we've done some fantastic research, certainly in Europe and here in the US, but I think it's been somewhat neglected, and I think this is a good opportunity to understand that better. In terms of teleoperations at the lunar surface, I don't know is the answer, and I think nobody knows. So people who are big fans of teleoperations will tell you that it's brilliant, but often I find if I talk to the teleoperations kind of engineers about what they think their crew are going to be doing, it's the exact opposite of what the scientists that I talk to think these crew ought to be doing. So there's a kind of a juxtaposition of expectation. I think what we're trying to do with things like Meteoron and Lucid is to do a rigorous scientific analysis of teleoperations and different aspects of that, so we can really understand what are the advantages, what are the disadvantages, how can we best use ground teams, crew and robotic autonomy to get the best possible outcome from these missions.
Actually, Carly's next. Oh, okay.
Okay, because I'm also ESA, but from different center. I'm from European Astronaut Center. So for answer your question about crew, we are already moving for training the astronauts from ISS to moon exploration. So already now we have a team. I'm here for this, preparing all the crew activity in the moon, concerning not only the training, but also the health program and the let's say, choreography or the EVA surface or the astronaut, and also the medical care, because if you have an accident in the surface, you have a broken bone is a broken bone, but to reduce it here and on the moon, it is quite differently. We are already preparing this, working on this.
Yeah, I think this is very important. Yeah.
One more question, Carly?
Okay, first of all, I love your optimism. That's what we continually need. And my question really links to the previous question in a related way. For long-term lunar exploration and science, communication is clearly a key component of that, which we don't have right now. And I was glad to hear you at least mention it. And I'd be interested in your perspectives or insights on two of the big needs that we as the international lunar community need, which is long-term relay as well as high bandwidth. We need these for any long-term exploration. I'd appreciate any perspective you have on how to go there.
Okay, so the perspective from the industry, from the commercial partner here, is that there are some things that are best for the commercial sector to do. If they do things like they run their communications, then we can get on with doing exploration. So they see that as a service they can provide, and we'd like to give them the opportunity to show us they can provide that service. This first mission is a pilot, so it's a self-contained mission, and the asset would then be available as a standalone asset. The bandwidth, it uses a UHF Proximity 1 link to other spacecraft in the area. That has a fairly low bandwidth. The bandwidth to Earth is X-band, it's a high bandwidth. The idea, though, is this is a pilot phase for later missions. Their aspiration is to create a solar system-wide network of high bandwidth data links, and this would be the first mission, and the Moon would be the first body. So their idea is that if they can close the business case, the indications are that for the first mission we can fill the manifest. That's the early indication. There's a call open at the moment. We have one customer who's pretty much signed up, and I think that there will be others that come. If you're interested, then talk to them. But if we can do that, then the idea is that they would launch additional missions with a higher bandwidth capability every 2 years to get global coverage of the Moon within a few years, in the mid-2020s.
Thanks, James.
Thanks very much.